Hi, Assalamualaikum and good day. Today we will proceed with chapter 2 that is on indeterminate forms and improper integrals. This session is divided into two parts. In the first part, you will learn how to solve the indeterminate forms, and in the second part, you will learn how to solve the improper integrals. These are the objectives of today's lesson. Hopefully, by the end of this session, you should be able to 1. Understand the definition of the L'Hopital rule. 2. Solve the limit of indeterminate forms of 0 over 0 and infinity over infinity. And 3. Solve the improper integrals with the infinite intervals. L'Hopital rule is useful in finding a limit of a rational function fx over gx with indeterminate form. Under L'Hopital rule, both numerator and denominator are separately differentiated first before the limit is evaluated using the new function. For example, if given limit of 2x squared plus 1 over x minus 3 when x approach to negative infinity, to solve the limit you need to differentiate both numerator and denominator separately. Differentiate 2x squared plus 1 is 4x and differentiate x minus 3 is 1. Replace the x with negative infinity and simplify, you should obtain negative infinity as the final answer. Generally, the limit of rational function of indeterminate form can be obtained using the following formula. In M81A3, you have learned how to solve the limit of determinate forms, that is by applying direct substitution. To find the limit of indeterminate forms, you need to apply the L'Hopital rule. Indeterminate forms here refers to the following 7 forms, such as 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, infinity to the power of 0, 0 to the power of 0, and 1 to the power of infinity. Indeterminate forms can be classified into 3. Type 1 refers to 0 over 0 and infinity over infinity. Type 2 refers to 0 times infinity and infinity minus infinity. And type 3 refers to 1 to the power of infinity, infinity to the power of 0, and 0 to the power of 0. In this chapter, you will only learn how to solve the limit of indeterminate form of 0 over 0 and infinity over infinity. To solve such limit, you need to apply the L'Hopital rule, that is by differentiate both numerator and denominator separately before applying direct substitution. Take note that L'Hopital rule can be applied more than once if the limit still leads to the indeterminate form. Refer to example 1. You need to evaluate the following limit of rational function. First, you need to identify the form of the function. By direct substitution, it leads to 0 over 0 form. To solve the limit, you may apply the L'Hopital rule directly, that is by differentiate both numerator and denominator separately. Differentiate sin x is cos x and differentiate x squared is 2x. Replace the x with 0 and simplify, you will obtain infinity as the final answer. Proceed with example 2. By direct substitution, it leads to 0 over 0 form. To solve the limit, differentiate both numerator and denominator separately. Differentiate 1 minus cos x is sin x, and differentiate x squared minus 2x is 2x minus 2. Replace the x with 0 and simplify, you will obtain negative 0 over 2, which is equal to 0. Take note that when 0 is divided by any number, the answer is always 0. Now, refer to example 3. By direct substitution, it leads to 0 over 0 form. Differentiate cos x minus 1 is negative sin x, and differentiate 3x squared is 6x. Replace the x with 0 and simplify, it still leads to 0 over 0 form, meaning you need to apply the L'Hopital rules once again. Differentiate negative sin x is negative cos x, and differentiate 6x is 6. Replace the x with 0, you will obtain negative 1 over 6 as the final answer. Proceed with example 4. By direct substitution, it leads to the form of infinity over infinity. Differentiate 3x plus 4 is 3, and differentiate x minus 1 is 1. Limit of 3 over 1 is equal to 3. Next, refer to example 5. By direct substitution, it leads to the form of infinity over infinity. Differentiate 4x plus 1 is 4, and differentiate x squared minus 3 is 2x. Replace the x with positive infinity, you will obtain 0 as the final answer. Take note that when any number divided by infinity, the answer is always equal to 0. Refer to example 6. By direct substitution, it leads to infinity over infinity form. Differentiate x squared is 2x, and differentiate exponent x is exponent x. Replace the x with positive infinity, it still leads to infinity over infinity, meaning you need to apply the L'Hopital rules once again. Differentiate 2x is 2, and differentiate exponent x is exponent x. Replace the x with infinity, you will obtain 0 as the final answer. Next, you are going to learn how to solve the improper integrals. But before that, let me brief you the definition of the improper integrals. Improper integrals refer to the definite integrals that satisfy either one or both of the following conditions. The first condition refers to the infinite interval, and the second condition refers to the infinite discontinuity. In this chapter, you will only learn how to solve the improper integral that satisfies the first condition. That is, when it has negative infinity at the lower limit, or positive infinity at the upper limit, or negative and positive infinity on both limits. In total, there are 3 cases to be considered, and the method of solution to each cases are given as follows. Basically, to solve the improper integrals, you need to replace the infinite limit with a variable, usually t. Do the integral and then take the limit of the results as t approach to negative or positive infinity. Refer to the example on the right. The first example has negative infinity at the lower limit. The second example has positive infinity at the upper limit, and the third example has negative and positive infinity on both limits. These examples are known as the improper integrals with infinite intervals. In order to determine whether the given improper integral is converge or diverge, you need to refer to the limit. If the limit exists, then the improper integral is said to be converged and assign a value. But if the limit does not exist, the improper integral is said to be diverged and does not assign a value, meaning the answer should be either negative or positive infinity. Let's take a look at the first example. As the given interval has positive infinity at the upper limit, you need to use limit of t approach to infinity and integrate the function as usual. Integrate x to the power of negative 4 is equal to x to the power of negative 3 over negative 3, which can be simplified to negative 1 over 3x to the power of 3. Substitute the interval inside and replace the t with infinity. Simplify, you will obtain a definite answer, which is 1 over 3. As the limit exists, the function is said to be converged. Refer to example 2. As the given interval has negative infinity at the lower limit, take the limit of t approach to the negative infinity. Split the function first, then integrate each term. Substitute the interval accordingly into the answer and replace t with negative infinity. Simplify, you should obtain 1 over 2 as the final answer. As the limit exists, the function is said to be converged. Proceed with example 3. As the given interval has negative and positive infinity on both limits, split the integral into 2 by taking 0 as the cutting point. Take note that the first integral now has negative infinity at the lower limit and the second integral has positive infinity at the upper limit. For the first integral, we take the limit of t approach to negative infinity, and for the second integral, we take the limit of s approach to positive infinity. Integrate each term and substitute the corresponding intervals accordingly. Simplify, you should obtain positive infinity as the final answer. As the limit does not exist, the function is said to be diverged. To check your understanding on this lesson, please do the following question. In the next lesson, you will learn chapter 3 that is on partial derivatives.